Hello and welcome to section 9.2. Today we're going to look at the area of circles. So our learning target is finding the area of circles or using the area to either problem solve or to find another component of a circle, whether it be its diameter or radius. Now when it comes to the area of circles, it's all about knowing one formula. I'm going to call it a need to know formula. It's kind of a big deal. Area is equal to pi r squared. And so that stands for area is equal to pi times the radius squared. Once we know that formula, it's all about plugging in the numbers and maybe doing a little bit of creative thinking depending on how things are presented to us. So, for example, let's start off with a problem. Let's say we have a circle, not the best circle in the world, but it'll get the job done, and its radius is 12 millimeters. Okay, and we want to find the area of the circle. So all we have to do, area is equal to pi times 12 squared. Let me make my 12 a little neater there. 12 squared. All right. So you have to use order of operations and take care of this exponent first, and so you got a square of 12. So our area is going to be equal to pi times 144. For pi, you could either use 22 over 7. So pi could is about 22 over 7, or 3.14, and I'm just partial to 3.14. And so when we use 3.14 and we times it by 144, our final answer is equal to 452.16, and then millimeters squared. So we box it, we walk away. All right, so that's what it boils down to. Got to use the formula. Now, one thing let's do another example. So in this one, let's change it up a little bit. All right, in this circle, you're given a diameter, and its diameter is 14 meters. So in order to use the formula, we have to convert this diameter into a radius. So if the diameter is 14, the radius is equal to 7. After that, it's the same thing we just did. So area is equal to pi r squared. But instead of saying r, we'll say 7, and we'll square that. So we're looking at pi times 49. And when we crunch those numbers, we end up getting 153.86. And so, and that would be, meters squared, given our unit. And now this brings up kind of an interesting divide. So technically what we have done is come up with approximations. So really I should be using approximately equals that. If we want to do something a little more precise, or what we'll call a more precise answer, we're going to, and this is a fancy phrase here, leave it in terms of pi. So let me pull up the work we just did, or copy that down again, and show you what I'm talking about. So we used a decimal approximate for both of these. We said, hey, let's let pi equal 3.14, and that's how we got these answers right here. Well, again, we're rounding. We've chosen to kind of cut off pi at 3.14, even though it goes on forever. And so if we want a more precise answer, we actually are going to use something that almost looks like a variable expression. And so this is either really easy or really hard, depending on how you want to interpret this. So another way we could go about, like this first one right here, is, and leave it in terms of pi, is we say that area is equal to pi r squared, so 12 squared, and we leave the answer as 144 pi. That's it. Here, we realize that our radius was 7, and so we square that. The area could also be 49 pi. And what we've now done is we've left our answer in terms of pi. And it's not as it's a little more pleasing to the eye, but it's not as complete to our eye. I think we want, a bigger number. It's not 144, it's 144 times pi, which is a much bigger number than 144. But if you're asked to put an answer in terms of pi, that's what it means. And so it means you have to do less decimal arithmetic, essentially. So that's kind of neat. Now, I want to talk about maybe working backwards a little bit here. Let's look at this problem. Here we have a circle and we are told what its area is, and now we need to find out what the radius and the diameter are. The reason why I want to show you this is because there's one part of it that tends to trip up students. When we plug it into the area formula, 314 is equal to pi r squared, these two symbols tend to throw students off thinking like, well, what can I do with that? Well, the funny part, the thing that we have to realize is that pi is just a number. I mean, we use 3.14 so often for it that so if we want to solve for r, we need to divide by 3.14, divide by pi. I mean, that's what we're doing. So we're dividing both sides by pi, which in this case, let's just use 3.14 as our decimal approximate. And so if we kind of look at it as, 314 divided by 3.14, we end up getting 100 is equal to r squared. And now we have to take the square root because squaring and square roots are the opposite of each other. And r ends up equaling 10. So our radius here is 10. And if our radius is 10, then our diameter must be 20. And so that's how we work backwards. Keep in mind, it's totally okay to divide by pi. And depending on maybe what you're using, what the problem tells you, that might mean you have to divide by 3.14 or, wait for it, 22 over 7, which means you have to do the keep, change, flip thing that you do for fractions. So hopefully this is a nice little introduction to dealing with circles. It shows you about the area and how you can both either find the area of a circle or work backwards and find another component with the area.